on number 20 from our homework, we have x to the negative fifth, right? Okay. So what does that mean when you have a negative exponent? It turns into a fraction. It's 1 over x to the fifth. But we don't even really need to know that, or we don't need to do it for this. It's just important to know. Because it might help you see it better if it's 1 over x to the fifth. So now let's do f of negative x. So that just means that we're going to put a negative x in everywhere we see an x. So this x turns into a negative x to the negative fifth. Or it's 1 over negative x to the fifth. Oh, I hate it here. What's happening? Why isn't it working? Help! Is it really? Why isn't it presenting? Hold on. All right, so we have 1 over x to the fifth, and now I have 1 over negative x to the fifth. If it's a negative x raised to the fifth power, what does that mean? Does it change it to a positive, or does it stay negative? It stays negative. So this is still just 1 over negative x to the fifth, right? Is this the same as this? No. So it's not even. So now we check to see if it's odd by doing negative f of x, which means that instead of the negative being inside with the parentheses, I do a negative out in front of it all. So if the negative's out in front of it all, it still doesn't change it, because this was a negative inside and it was raised to an odd exponent. It stayed negative. So this is the same as this one. So since they're both the same, that makes this an odd function. So it's even if these two are the same, and it's odd if these two are the same. What about number 22? Did we do number 22? Yeah, whatever. I don't think so. All right, we have x squared plus x. What do I do first? Check to see if it's even, and I do that by plugging a negative x in everywhere I see an x. Negative x to the second power. What does that do to the negative? Good, it makes it positive. So that's just x squared now. Plus a negative keeps it negative. So now it's x squared minus x. Is this one the same as the original? No, so it's not even. Now we do a negative in front of it all, right? So I go back to my original, and now I'm just putting a negative in front of it all. So now I do x squared, and then times a negative 1. That gives me negative x squared. Then negative 1 times x gives me negative x. Is this the same as this? Correct. This one's neither because this has the negative in front. So it's neither. Now I have x to the fourth plus 3x squared minus 1. I want you to try this one. See if you can figure out whether it is even, odd, or neither. A negative x in everywhere we see an x. So it's negative x to the fourth plus 3 times negative x squared minus 1. This is working out real well. Okay, so what's negative x to the fourth? What's that become? Just x to the fourth. What about negative x squared? If it's good, it turns into plus 3x squared. Yeah, still, anytime that I raise this to a negative to an even exponent, it's going to become a positive. Okay, so now this is exactly the same as this. So this is an even function. Since they're exactly the same, it makes it even. Make sense? Roland, number 26. This one is x over x squared minus 1. How do we start to check and see if it's even or odd? We put a negative x in. Everywhere you see an x. So this is now a negative x on the top. And negative x squared minus 1. Negative x on the top stays negative. On the bottom, this negative x squared becomes positive x squared. And that's our answer. Is that the same as this? No. So it's not even. Which means I take a negative out in front of everything. Take the whole thing, put a negative in front of it. Now that really just means I can either multiply the entire top or entire bottom by a negative. Generally just do the top. Just going to make it negative x over x squared minus 1. Does that make it odd? Yep. So this is an odd function. Look at number 28. We have the absolute value of t to the third. So let's do h of negative t. It gives us the absolute value of negative t to the third. Negative t to the third, it stays negative. But what does the absolute value do? Right, it's going to make it positive. So that just becomes t to the third. Because my absolute value of t to the third, like no matter what I put in for t, the absolute value is of negative t to the third is going to be the same as t to the third. Because the absolute value is always going to make it positive. So this is actually exactly the same as having t to the third. So this one is even. Because whether it's positive or negative, it's always going to come out to be t to the third. Or not necessarily even t to the third, but a positive number anyways, whether it's positive or negative. So look at 30, same exact concept. So as to make that h of negative t, that becomes 2 times the absolute value of negative t plus 1. Whether this is a positive t or a negative t, it's always going to end up being a positive value. So this one would also be even. Any questions on those? It cannot be even and odd. It can be neither, but not even and odd. Do we know what an even function looks like? I don't know that we necessarily. So like we said, this absolute value of t to the third was even. If I look at that from a graphical perspective, you see how on the left side it mirrors exactly what it looks like on the right? All even functions are going to look like that. The left side is going to look exactly like the right does. And so even though I'm going to have you show your work on the quiz, like I'm going to say if you have to show your work, even if like you get confused about, hey, maybe this is even, and I'm not sure if I did it correctly, then just graph it and see if it ends up being exactly the same. If it does, then it's going to be an even function. If we look at one of our ones that was odd, I think this one was odd, correct? 26. If we look at that one, that was x over x squared minus 1. This one's a little different, but you can tell if it's even or odd if it actually rotates or reflects over the origin, which is this point here. So it's a little harder to see that. But if it flips over, then it makes it odd. Like this is a hard one to even recognize, but like if I do x to the third, See how if I flip this side across the origin, or across the line, y equals x. If I flip this down this direction, it's going to make that be exactly the same. That one's hard to describe. Evens are much easier because your reflection is directly across the y-axis. So both the left and the right are the same for evens. All right,